Hi everyone, welcome to this webinar. As some of you may know already, I'm Ilona and I work at Telecentres Europe. And together with my colleague Laurentiu, we are coordinating this campaign. So just a few words before we start. This is the first coding campaign organized in telecentres and also organized by us. We have 10 partners that will be organizing coding activities in 9 countries. And basically the idea is to introduce coding to young people and children in your local communities. And the main objective of the campaign is to help and develop competencies of your staff who are working as trainers and telecentres, so that they can organize later coding classes to young people and kids coming to your organizations, coming to your telecentres. So this is the first phase, train the trainer phase of the campaign. And we will have today the first webinar and the second one on Monday. And Anna is our trainer. She will be running webinars. And before I pass the word to her, I just like to thank to Anna for joining us, and also to our Polish member and partner of this campaign who agreed to host the webinar. Thank you. I hope you will enjoy.
Thank you, Ilona, and we will now start the presentation, and the floor is yours, Anna.
Hello everyone, thank you for the introduction. I am very excited to have the opportunity today to talk about teaching young people and children coding. This is the first webinar called Code Your Future. It will be about TouchDevelop, a tool from Microsoft that helps us teach young people, introduce them to programming and coding. We will have more chapters in the presentation today. We will talk about the basics of computer programming, like about instructions, algorithms, data types, procedures. Then we will switch to computer games and why they are important in teaching coding. We will see what TouchDevelop is, Kodu, Scratch, and other tools. We will go into details about TouchDevelop, like creating our first game. And then we have time for questions and answers at the end of the webinar. If you have any questions, please do not hesitate to write in the chat. If we have time during the webinar, I will get to them. If not, then at the end, we will see how many questions we can answer. I will also shut down the video because it will help with the connection. Let's see how this works. I want to introduce myself. My name is Anna. I'm a software engineer with more than 10 years of experience. I worked as a developer, a team leader, project manager, consultant, and now I work as a trainer for young people and adults as well. In my free time, I do Coder Dojo sessions, which are very similar to what you will be doing, meaning teaching children how to code. And I also organize events for programmers. So getting back to our webinar. The scope of this webinar is not to teach you how to program. That cannot be done in 2 hours, unfortunately. But we will help. I will help you learn TouchDevelop, to write simple programs with it, to understand how it works. I will show you where to find further learning resources and how to assist young people and children in coding. You are very lucky because teaching young people to code doesn't mean you have to learn to code very well by yourself. I will show you the tricks and the tips that are needed to be successful with it. It is very important to know I did not use this picture by accident. It takes many hours of experience and learning to learn how to code. So I recommend that you get your hands dirty like this person here and experiment with all kinds of tools that we will run through. So our first step, programming. What is programming? I call it an art, the art of creating computer programs. It is more than just science, because it takes more than just writing instructions and learning. It works with your creativity a lot. So the art of creating computer programs. We all know what computer programs are. I listed examples here. Microsoft Word, Internet Explorer, we all use these. Skype, Paint, Solitaire. And Facebook is also a computer program. It doesn't run on your computer, but it is a computer program still. Or the tire pressure indicator in the car. Your car has a tire pressure indicator that runs on your computer, the car computer on the central system of your car. It is also a computer program. These programs do something. They have a scope, a reason. Microsoft Word creates text documents. Internet Explorer helps you look up information on the internet. Skype, you chat with other people. You create pictures. You look for entertainment. You manage social connections. Or you look for warnings for tire punctures. It is very important that all computer programs have a task that is mainly a verb. I highlighted here: create, look, chat, entertain, manage, warn. When we look at a computer program, when we think about creating one, it is important to find this verb, what it actually does. Then it has the object, like chat with people. I don't chat with robots. I create pictures. I don't create documents with Paint. I create pictures. And so on. I use this example of the tire pressure indicator because it is a very simple program from the computer's perspective, and it helps us understand how we have to think when we look at computer programming. What does the tire pressure indicator do? Well, I tried to chart it down. You have in the front right wheel of your car a sensor. The computer program reads the value. It sees, well, the pressure in my car is now 2 bars. And it thinks, how is this pressure? Is it the same like last time I checked it? If it is, then nothing happens. I just wait, I as a computer program, and read the value again in 1 minute, for example. When I read the value again of the same sensor, I look at the value. Is it still 2 bars? If it is, then no problem. But if the value is 1.5 bars, for example, then I detect a change in value and I decide to show a warning. So I show a warning on the computer of my car on the display. This is for one wheel only. But I have more than one wheel. The logic is no different. For every wheel I have, for every sensor I have, I use the exact same logic. Check the sensor, I read the value. If it changed, then I show a warning. If it didn't, then I check again in 1 minute. Of course, the logic behind it might be a bit more complicated. There might be more values to check, like is the pressure, the back wheels of my car the same, and so on. Tolerances. But in the end, when we draw a line, this is the logic behind it. This is called a flowchart, and it helps programmers sketch down what they want to achieve with their program. We sketched an algorithm. What is an algorithm? The definition is a self-contained step-by-step set of operations to be performed. Meaning, this is what my computer program has to do. These are the steps it has to take to achieve the goal I designed it for. Check pressure in the wheel. If the value changed, show warning. Programming is basically a collection of a sequence of instructions applied to objects and tests. We have in our algorithm some objects, the sensor in the 4 wheels, and we also have the display indicator in my car. I used some instructions. I said sensor, read value, or I said display indicator, show the warning. Not every time, just if the value changed. So I can also run some tests. Is my previous value bigger or smaller or the same as the next one? So I check values and I compare them. If I were to translate this logic into a made-up programming language, it could read something like the text below. I say, my current reading is something what I read from the sensor in the front left wheel. So sensor front left, read value. If my current reading is lower than the previous reading, then display indicator show warning. As you can see, I'm an object like current reading, sensor, display indicator, colored with blue here. I give them instructions, read value, show warning, and I do a test. This would be a very simple computer program in a made-up programming language that I made up for the purpose of this webinar. There are many programming languages. Programming languages are the way we give instructions to the computer. I always say that programming is like teaching your children to live. When you get a new baby, a newborn baby, first you teach it how to eat and how to walk, and then you give it instructions. You say, son, try to stand up still, or son, please sit down or be quiet. As your child grows, you give it more complex instructions, like clean your room. When you tell your son, go clean up your son knows what he has to do, because you already taught him that clean your room is go inside your room, check if there are any toys on the ground. If there are toys on the ground, then you have to pick them up. If there is dust on your table, please wipe the dust, and so on. Simple instructions that, if you put them together, can make up a very complex behavior. You talk to your child in the language, within your own language, for example, English. You can call that the programming language of your child. In the same way, there are programming languages for computer programs. Binary, assembler, C, C++. These are all programming languages. The beauty of it is you don't have to learn all the programming languages to program. And once you learned one, it is very easy to learn the rest. Binary is the first very primitive programming language. Some of you might remember the punch cards we've seen in university or the television, pictured here. This is binary language. There are assembler languages which are a bit more easier to use, but still very similar. And then C, C++, Java, and so on. What we are going to learn today is the language TouchDevelop uses, which is neither of these. It is a very special language for young people to learn coding. The principles are the same though, so once you learn TouchDevelop, you easily learn Java or JavaScript or whatever you or the children you instruct and the young people you instruct. There are many tools on the internet and also for the computer offline to help us get into coding. One of them being this code.org website, which I would like to show you how it works. It's a series of puzzles designed for young people. You know, young people are very attracted to the game called Minecraft nowadays, which is a very simple universe made out of blocks. And people saw that young people are attracted to this game and that it could be used to educate them further. I would like to share my screen and show you what it is about. Can you see my screen? Maybe you can type in the chat if you can see my screen. Perfect. So, the purpose of this little game here is to instruct the Minecraft character to reach the sheep. On the left-hand side, you can see a character, and you can see a sheep. And on the right-hand side, over here, you can see instructions. If I run this game, I click on run, the instructions on the right-hand side are executed. The instructions are move forward, turn left, or turn right. Of course, I did not do anything. I did not program my computer character, my game character, to do whatever it has to do. So I will tell him move forward 2 steps, so move forward twice to reach to the sheep. And I click on run. And I can see that I finished my game. This is a very simple and fun way for young people to get into coding. They start by playing a game, but in the end, they are writing code. I will switch back to the presentation now. So we issued some move forward commands for the Minecraft character. As we progress with the puzzles, we see that it gets more and more complicated. Besides the move forward commands, we have place some items on the screen. We have repeat instructions. This puzzle number 6 here gets very complicated in meaning that we combine all sorts of commands to achieve the task that is on our hand. It is very interesting that with this Minecraft example and also others that are on the Hour of Code program on code.org, you can also see the equivalent code in a real programming language. So what the children are doing here is not using any specific programming language, but it can be directly translated into JavaScript. There is a button, show code, on the screen here. And kids and young people can easily see what their code would have looked like had they used JavaScript from the beginning. It is very similar, and it is a very good way to move from a very simple drag and drop interface to JavaScript coding. The repeat instructions are translated, so we have repeat here. It is translated to a 4. The move forward command is still a move forward command. Place block, place block. It is very easy to learn. I would like to commend everyone to this game. It takes exactly an hour to finish all the puzzles, and you learn very much. After you finish the game, you can look at the code, try to understand what the instructions are exactly. I would like to focus on the commands. There are 3 types of commands used. They are differently colored. We have move forward, turn left, place something, destroy block. These are the blue commands. They are very simple. They instruct the character to do one thing. Then we have the repeat. No, it is not Scratch, but it is very similar to Scratch, David. I see your question. Scratch is also very similar, but it uses a bit more complex blocks. After, I usually instruct kids the Hour of Code for 1 hour, finish Minecraft examples, then switch to Star Wars, and after that we go to Scratch. So we have the repeat instruction used here. And we have this very special when run. When run. It is important that the character knows when to execute these commands. So not every time, but only when I hit the run button. So when the user clicks the run button, repeat 3 times, move forward, place blank, move forward, place blank, move forward, place blank, and then turn to the right. This is a very simple computer program run in the browser. Kids love it. Okay. We started talking about commands and instructions. These are the basic building blocks of any computer program. This is a picture of my dog here, and I'm trying to teach it different tricks, just like I try to teach my computer to do things I want. So far, my dog knows how to do two things. He knows how to sit, and he knows how to roll over. That is it. He does them very well, though. I would like to teach him a new trick. But before that, was I to translate the two commands I use to my dog into a programming language, it would look like this. Dog stand still, dog roll over. Yes, if dog can do it, you can do it too. So I instruct the dog, my object, to do an action, stand still. Very hard, but he learned how to do it. The new trick I want to teach my dog is play dead. How do I teach my dog to play dead? Very simple. I tell him stand still, I tell him roll over, and then stand still again while you're on your back. It is very easy. I translate this into 3 commands my dog already knows, and I define a new behavior for my dog. So I define the command or the instruction play dead as a sequence of 3 commands my dog already knows. This sequence of commands, stands over, is called a feature in programming jargon, or a subroutine, or a function, or a method. It really depends on the environment you're in, or the programming language you are using. But whenever you hear procedure, subroutine, function, method, or even message, then you know that it is some behavior my computer program or an object of my computer program knows how to do. In this case, a combination of 3 things they already knew. There are several types of instructions. The basic one, the most basic one, is attribution and data handling. Now we switch a bit to a more abstract level from instructing dogs how to do things to instructing computers how to do things. When I define a new variable, in this case my lucky number, I basically tell my computer, remember that whenever I refer to my lucky number, I actually refer to 13. This is the basic attribution or basic variable definition in programming. There are several ways to do it, depending on the programming language or environment you are. Some use var to tell the computer that I am defining a new variable, a new alias. Some use int, meaning it is an integer, a whole number. Some use equal. Some use this symbol, semicolon, and equal to define the value of a variable. I can also combine the instructions. I say, okay, my lucky number is 13, but your lucky number will always be my lucky number plus 1. So in this case, 14. But if I change my lucky number to, let's say, 0, then your lucky number will no longer be 14, but it will be 0. This is a cross-reference, and combining, sorry, not 0, 1. Combining several instructions and several attribution commands into obtaining. Okay, attribution and data handling was that. There are also other types of instructions. Calls. I call up some behavior I already know, the computer already knows. Like in the example before, dog play dead. I defined the play dead behavior, and when I write this line of code, then I tell the computer, make sure the dog executes the play dead subroutine, play dead instructions one by one. So he will sit, then he will roll over, and then he will stand still until I tell him to do otherwise. This is called a call. I call a behavior I already know how to execute. There are also other control flow instructions like decisions. Like there is no person in this world who hasn't made a decision in his life. Computers also need to make decisions. For example, I want to define John's lucky number, and it really depends on mine, because if my lucky number is 13, then I don't want John to use that as his lucky number. Then I want John to have to use 7 as his lucky number. However, if my lucky number is something else, then John can have 13. So this is a basic decision. If some condition is satisfied, my lucky number is 13, then do this. Otherwise, do the other thing. I can use different conditions. I can say, well, if my lucky number is lower than 20, then do something. I can use this different operator. If A is different from B, then do something. Or even complex expressions. X is exactly 0. This, if X is exactly 0, or, this is or, X is larger than 50, and it's exactly divisible by 2, here, then do something. I don't want to get into the details of these expressions because they can be quite complex, and it doesn't help necessarily a lot with your purpose of assisting young people and children in learning and teaching them how to code. But it is important to know that you can make these complex things, and that you know what they mean approximately, and then you can look them up on the internet later when you need them. So these were decisions. If something, then do this, otherwise do something else. The most important, in my opinion, control flow instruction is the loop. Computers are very good at doing things repeatedly, and that's why they are very helpful in our daily lives. They can repeat things over and over again, and they don't get bored. That's why they can replace us in our daily jobs. So, for example, my computer can make sure that while me as a human is working, make sure the dog plays dead and does not bother me. This is a repeat instruction or loop. While this condition is true, so while the human is working, make sure the dog plays dead. This can happen over and over and over again. I have this other type of instruction, the for, do. This basically makes the dog roll over 10 times. While the counter, here, the counter, is between 0 and 10, do this. It will first go in this instruction, and it will say, oh, well, the counter is now 0, so I make the dog roll over. Then the counter is grown by 1, the counter is 1, and it goes again and makes the dog roll over. And then the counter becomes 2, and so on until it reaches 9. And then the dog rolls over. It rolls, the counter takes values from 0 to 9. And there are exactly 10 values in these. So that's why the computer makes the dog roll over 10 times. Okay. These were for loops or while loops. We will also talk about data types. A few minutes before, we talked about my lucky number, which is a number, a whole number, an integer. But we can also have other things of data stored in variables. We can have a text, like hello, a greeting. The greeting is of type string. This is what it is called, a string. There are other data types as well, like a Boolean. A Boolean is a data type that is either true or false. For example, is it raining? I say it's true, but is it cold is false. I can use this kind of data in creating my if-then-else conditions. So if it is cold, then do something. The numbers can also be float numbers, like 13.7. But then it's no longer an integer, but it is a float. I type it here in the chat, float. But it really depends on the programming language, and it is not necessary to get into too much details, because the tools that young people use to learn to code don't go into such depths when writing programs. Okay, so we talked about instructions. We had attribution. My lucky number is 13. We talked about calls. I call dog roll over. We talked about decisions. If it is called, then do something. We talked about loops. While something is happening, do something else. Or for loops, do something 10 times. These are the building blocks to any computer program, no matter the language. Instructions, and then we put them in a sequence, and then we get the result we want. So basically, programming is using instructions and objects and testing them. We talked about algorithms. Algorithms are the logic behind any instruction, any computer program. We talked about data, that it can be a number, it can be a string, it can be a Boolean, which is a very simple data structure, and also more complex things, but you don't have to worry about them very much. Okay, if you have any questions, please write in the chat. I'm happy to answer them. If not, then we go on to computer games and coding. I love computer games, and I use them very much in my classes with children. And it happens often that a new child is coming to class, and the parent brings the child to the class, and I ask them, why did you decide to join, or why do you think your child needs to come to coding classes? And they usually say, well, they spend so much time on the computer playing that I think it is time they do something useful and learn something. And I always laugh, because I personally think computer games are very useful, not in excess, so not playing all day, but they're very useful for the development of the critical thinking of young people. Basically, a computer game is a translation of a real-life scenario into an abstraction. It helps children visualize and imagine things that are not necessarily on the screen, and make conclusions and filling gaps. This is what coding is also about, translating real-life scenarios into abstractions, into abstract things. This Minecraft example in the Hour of Code is a very, very good example. It gets children into coding in under an hour, and they will never stop if it's so much fun for them. There are a lot of tools to help this. TouchDevelop and Code are two examples of Microsoft. Scratch, David mentioned Scratch before. It is also a very good tool. It is made by MIT, the university in the United States. Also playable in the web, on the web, and you can do amazing things with it, just like with TouchDevelop. Code.org, the website I showed you earlier. And then more complex websites like Codecademy and Khan Academy. They teach you real programming languages. So Scratch, TouchDevelop, Kodu, and Code.org mostly teach these made-up programming languages that they only serve to teach you how to think. Codecademy and Khan Academy, they go into complex programming languages like Python and Java and JavaScript and web development. A lot of tutorials that I use extensively, because in a class when there are 25 children, you can't be there for every one of them. So we start up with a tutorial, and if they get stuck, then I help them. Code Academy is a very good tool for that. Lightbot is also an interesting game. It is available, I think, on all iPads and Android devices, and maybe also the web. It is about programming a robot, very similar to the Minecraft thing, and it's useful for children up from 4 years of age, I think. It's very nice. This is the Minecraft example I told you about, how it can quickly get very complex. In the end, programming improves your children's problem-solving and thinking skills. You have to think about programs as puzzles, and puzzles are games. When you solve a puzzle, you solve a problem in the end. It helps you think differently than you thought before. It helps you think outside the box, and that improves the connections in your brain. It's very similar with programming too, except that when you program, you solve 1,000,000 puzzles every day, not just one. With a puzzle, you solve a puzzle and that's it, and you have no more incentive to solve it again because you solved it once. But with computer programming, it's a continuous puzzle. You always have new problems you have to fix, and you always have new challenges and new improvements you want to implement. With kids and young people, what works very, very well is challenging them to improve or customize a puzzle, a game they played. For example, I had an 8-year-old child come into class, and he got bored of using Scratch, and he started playing this game, Agar.io, or whatever it is called. Agar.io. It is very popular with kids. I didn't know, and I saw that he is playing, and I asked him, show me what this game is about. I want to know about it. And he described the game to me. It is about you're a dot on the screen, and your task is to eat dots that are smaller than you and run away from dots that are bigger. It is a massive multiplayer online game or something like that you play with your friends. And he played that, and he said it is very exciting and very cool, and it is more interesting than playing with Scratch. And I asked him, what don't you like about that? Very similar to Pac-Man, yes, except it's a free board. You don't have to run in a maze. You can run anywhere. And I asked him, what don't you like about it? And I get my score grows very slowly, and I would like to get more points. And I asked him, can't we do that with Scratch? Let's make our own Agar.io game. And he was so excited that next 3 hours, all he did was program an Agar.io game in Scratch, and he did it. And it wasn't a multiplayer online game, but it gave him 10 points every time he did something, and he was very happy that he got to customize the game that he loved the most. So it's a success story of mine, and I encourage you to do the same. So when you see the young people are no longer attracted to the class you are teaching or the curriculum, then see what they like better and try to build on that. It works very well, especially with these tools like TouchDevelop and Scratch. And what's also very useful is start with ready-made examples. TouchDevelop has a very nice tutorial I will show you later called Flatverse, which is exactly this, Agar.io made in a different way. And once the children see the example, they try to understand it, and they look and they change little things, they adjust little things, and step by step they get to learn the entire program, and they will say, let's do this from scratch because I can do it better. A very simple example is take a game that somebody else made and make your students change the scoring system. So instead of giving them 1 point for every success, give them 10 points. They get very excited about that. Okay. One more thing that is very, very important for me, at least. When I started teaching programming to young people, it was a crisis scenario, meaning that a friend of mine couldn't go to class and asked me to replace him, and I had no idea about Scratch and the tools they were using. So I went into class with 30 kids, and they all asked me questions like, I don't know how to do this, I don't know how to do that. And I didn't either, so I told them, okay, let's see, you have this problem. Why is this exactly a problem? And they started describing the problem to me. And most of the time, as you ask the questions, they figure out by themselves what is wrong and what they have to do. It's very, very important and very useful. You don't have to know everything that's happening in their program. You just have to know to ask questions. Ask questions all the time. What is the problem? Why do you think this is a problem? Have you seen this problem before? How did you solve it then? Don't know. Do you think you caused this problem, or when did this problem appear the first time? Questions like this that don't necessarily indicate the solution by itself help them figure out by themselves what they have to do. Do you have any questions until this point? I'm happy to answer them. If not, great. We will. No, I instructed him to stand up. The dog is not doing the play dead thing. We will talk about TouchDevelop now. TouchDevelop is a tool in Microsoft. It is a web application. You run it from the browser. I use Chrome, but it runs in Internet Explorer and Safari and Firefox. It also runs on any tablet, and it is designed in a way that it can be easily used on a tablet or a phone. It's very nice. It helps you by suggesting the next step you have to take. I had some trouble at the beginning with it, understanding how it works, but once you understand how it works, it is very easy and very nice. Maybe I will like it even more than I like Scratch, but I still have to decide. This is the interface. If you log on to touchdevelop.com, you launch the development environment. After you log in, you can log in with Facebook, Google, LinkedIn, and all those things. This is what the interface looks like. You have the section called My Scripts, where everything you ever did or edited or touched appears. You have tutorials. And there are some ready-made tutorials by Microsoft that are attractive because they're very similar to popular games, like Flatverse. Flatverse is this Agario clone that I talked about. Or Jumping Bird tutorial. Maybe some of you have heard about this game called Flappy Bird. Yes, that's what it's called. It is a very simple game. It's very attractive and addictive. And somebody made it in TouchDevelop and created a tutorial for it. And of course, that can also be customized. Like an idea of customization, you get the young people to look at this code, look at Jumping Bird code, and make it that if you hit the second pipe, remember there were some pipes, then don't die. And it's like introducing a cheat. Introducing cheats gets young people very excited because only they know of the cheat. And then they feel very special and very powerful. It gives them a sense of success and achievement. So we have this MyScript tutorials, some information about yourself, and as you scroll down, there is this section called Learn, where you again have access to the tutorials, to the documentation, some resources for teachers, and I strongly encourage you to look at them. You won't learn everything in this webinar, and the tools that the resources that are there will help you answer more detailed questions. So something I ran into was a skill level coder. You can change the way TouchDevelop looks like from beginner to coder to expert, but I strongly recommend you don't change that because there are some bugs in the web interface, and I don't know if Microsoft is still working on it. But I had to restart TouchDevelop several times if I accidentally changed this skill level. Be wary that this is a buggy feature from Microsoft. And there is a showcase of programs created by other users in TouchDevelop. For example, my mGeometry. If I click on mGeometry, it will take me to the project page of the program. It describes the program here, when it was made 3 years ago. You can edit the code, you can play the game, comments, and then the creator can answer any comments or questions you might have. You can share all those modern things, and you can print the code. Also nice. On the left-hand side, and this is typical of the TouchDevelop interface, you have the list of projects, in this case in the showcase. When we edit the program, we have a list of items that we have in the code. You can search here. This is a typical interface. Okay, if I click on run or play, it starts the program. In this case, it is a geometry app for teaching how to calculate area and mathematical things, and surface and things like that. If I want to see the code, I click edit here, the edit thing, it will take me to the code. This is the main function, the main behavior described here. This is the main part of the application. We have other resources, other functions, other procedures that were defined by the creator of this app. Here we have some variables defined, or actually all of them. Known values, container width, container height, and I don't know what variables he uses in the app. And you also have some calls. This calls functions. Sorry, yes. Calls functions in his code. Just to show you an example of a complex app somebody created, you can take a look at this, and then you can modify it, see what happens. And once you modify it, it shows up in your screen, in your MyScripts here. And you can customize it, and it's very helpful. For the purpose of this webinar, I created a very simple game called the Unearthly Ball Game, and I would like to demo it with the YouTube video I created. Let's see. Ready? For some YouTube video is not playing. Let's see what is. Figured it out. So basically, it's a very simple game in which there is a ball, and every time the user taps on the ball, the ball is jumping up and down, and if you drop it, then the game is over. I think it's called hoops or something like that in English. We have a customized game experience for little boys who play football, with a background and the funny looking football. And we will try in this webinar to recreate this game. I hope everyone saw the video. Every time we create a program or a video game, we start off by creating the abstractions, trying to translate what we want to achieve into a language that the computer understands. As a first exercise, I would like to ask you to use the whiteboard . On the whiteboard, you can see some words, some objects. And I would like to ask you to underline or circle all the objects you've seen in the game and you think are relevant for the game we are going to develop. Okay, so basically everything is very useful and important for the game we are going to develop. Yes, that is somewhat true. And I can't see anything. Okay. Okay, let's get back to the slides. We talked about creating abstractions, and the objects you circled were all correct, of course. I select few, like the ball. The ball is an object, the most important object in the game. We can describe the ball by its position. It has an X and Y coordinate on the game board. It has a speed, it bounces, it has a bounce factor, I called it. And it can be tapped. This is how I can describe the ball. It also has a picture. It looks like, I think it was a Nike football. We also have sounds. Maybe you've heard in the YouTube video, a sound can be played. Whenever I click on the ball, a sound is played, and when the game ends, again, another sound is played. We also have the board, the game board. It has a height, a width. It has a background picture. Lives, yes, lives is a very common concept in computer games. You die and resurrect because you have a number of lives. But in this game, I chose the real life scenario, in which once you drop the ball, the game is over. So no lives are used, just for the simplicity of development. Okay, I will try to share my screen and try to recreate this game in TouchDevelop. Okay. I hope everyone can see my screen. I will try to go slow so you can follow whatever I do. The first step I will take is create a script. A script is a synonym or another way of saying a small computer program. A series of instructions, not very complex, just jargon. So I will create a script. Oops. And TouchDevelop has several templates from which I can choose. I can choose a blank, empty script, it does nothing. I can choose a blank game. It gives me the basic building blocks for creating a game. But also an app, something like the geometry game, which was constructed as an app. It had inputs and things like that. And also other options. It also connects to Scratch. It has a Scratch library. David, I think, asked about Scratch. And a Minecraft. Very nice to explore. I recommend you do that when you have time. But in this case, I will choose a blank game. I can give it a name. I will call it Code Your Future Curious Football Game. Great. And because this was a template for games, I already have some of the code that I will need. I have a main function. I have some artwork already associated to the game. Hope you can see. Some libraries, but let's not go into too many details. What happens if I click Run? Let's see. I know you can see it with a slight delay, but there is a monster on the screen that jumps up and down. I hope you can all see this. It is a good starting point for my game because it already has an object that is moving on the screen, not the object I want, but nevertheless an object. I will stop the game by using this button, and my monster stopping, and nothing is happening. Good. We also have 3 lives indicated on the screen, 3 little hearts, and a score on the right. Okay, let's get back to coding. So this is very similar to what I want to achieve. I already have the basic building blocks of my code. I have an object on the screen that keeps moving, and I'm bumping on the screen. I already have some code, so let's try to change it step by step into what I want, the football game. Okay, the first thing I will do is change the monster. I don't want a monster in the screen, I want a football. The monster is this picture here. This is the picture that was jumping up and down on the screen. I will change the picture. TouchDevelop has a big library of all kinds of artwork. I will just change it to something else. I clicked on Search Art, and I will say, show me a football. I don't want to use this Nike football anymore. Maybe something else. I will use this one. It's golden. Okay, so I have a football. But it's no longer a monster, so I will change the name of this art resource into football. Okay. I go back to my main function. I notice that something changed in my code. I had a variable called monster that was using the artwork and now is using the artwork football. It automatically changed. If I renamed my artwork, it also renamed the artwork in the code. I will also rename the variable. I click on monster, the variable name, And then I click on rename here on the screen, and I just call it ball. This instruction, var ball game create sprite football, is the line that draws the football on the screen. A sprite is a computer programming term that is used in game development. It's basically an object that is printed on the screen. It is the picture. Usually computer games are made up of sprites, and when you draw a sprite, you draw an object on the screen. Okay, so if I run the game now, I suspect you all know what is going to happen. I will no longer have the monster, but I will have a football on the screen. And that is not happening. Why? Because I did not do something right. I do it again. Football. Okay. Create game. Let's do it again. Great. So now I have a football on the screen. The first step into creating my football game is now done. What I will continue to do is remove this lives indicator here on the left side. To do that, I have to give my game the instruction not to show the lives. In order to write code, every time I want to write some code, I select the place where I want the code to be. So from the very beginning, after the get ready line is shown, the get ready text, I want the game not to show the lives. So I will say game. Here are the instructions that I can give the game object. I have bounce on sides, but it's not what I'm interested in. Create sprite, splash, start, and all sorts of things. Here I have more instructions. Let's see what else is possible. I have set life visible, and I will say I don't want the life to be visible, so I say set life visible false. Now if I run my game, I probably won't see the hearts on the screen anymore. Which is true. On the left hand side, there are no more hearts visible. Here. Okay. I've created another step into achieving my goal. The next thing, I want to add a background picture, the football park in the background, because it is very white and I don't like it. For that, I need a picture, so I will create another art object. On the left-hand side, I have everything my code uses, and I want to add a new picture resource. And I will call it park. And I will search for a picture. Perfect, there is a football park right here that I'm going to use. I can also upload a picture from my computer or just paste a link to a picture on the internet. Good, so I created my park, the park is right here, and now I want my code to use this picture as a background image for my game. This means I have to add a new instruction. This is the background picture is not a property of the game itself, it is a property of the board. So I will click here. I will say add a new line of code, a new instruction. I say board You can see that TouchDevelop already has some idea of what I want to do. It suggests I should click board, set background. No, this is not it. I want to set background picture. Perfect. Set background picture, and I have to select a picture that I will want to add. The picture I selected is available under Art. Art, Park. Perfect. Now I have this instruction board, set background picture, park. If I run, I have a football that is jumping up and down the screen, but it is a square. I wonder why. The reason behind it is that the picture is not round, but it is a square. And it would be better if I select a picture that has transparent edges. So I will change the picture right now. I go to football. I will search for pictures. You can see which picture is transparent if you look at the edges of the ball right here. I will use the Pokeball. It's more fun. Good. Run. Now I have a Pokeball running up and down, jumping up and down the screen, and no white edges or squares visible. Good. It probably won't be visible for you, but now if I tap on the screen, the ball keeps jumping up. But the thing is, the ball keeps jumping wherever I press. If I press on the screen, the ball keeps jumping up. This is because there is some code that has already been generated by TouchDevelop. It says gamepad on button pressed, do. Set some speed to the ball. I don't want that in my code, so I will just delete it. I click on the line that I'm not interested in. I say select. TouchDevelop already knows that I want to select this whole area, and I just say delete selection. Now if I run the game, no matter where I tap, the ball is only jumping because it is falling on the ground. So not because I am tapping. Okay. The next step I want to achieve is I want the ball to start from a higher up position on the screen. For that, I will stop sharing my screen and I will talk about the game board and its coordinate systems. Let's go to the whiteboard, if I can find it. Okay. So the game board is basically a rectangle, as you see in the screen. It had initially it had 3 lives here that are no longer visible because I deleted them. It had the ball in the middle. Let's say this is the ball. Then it had the score here, 0, and the stop button. My drawing skills are very good, as you can see. Okay, and so this is the game board. The game board is a rectangle that has a width and a height. So this is the height of the screen, and this is the width. every item that is on the screen is placed at a position. It has an X and a Y. The ball starts from the middle of the screen, from right here. And let's say X is 300. And Y is also 300. I don't know exactly the values, but this is just from a guess. What is important to know is that the coordinate system has the 0, 0 point here on the top left corner. So this is where I count 0, 0 from right here. The ball, in this case at 300, will be placed at 300 in this direction, and then 300 in this direction. If I want the ball to start from higher above, then I will have to add, I will have to change the Y position to a lower number. So in this case, let's say 50. And the ball will start from somewhere over here. I hope that is clear. A tricky thing is that if I have an item on the screen, we'll delete this. Wow. I have an item, let's say another ball. It is basically a sprite that is placed in a rectangle. It also has a height and a width. But the position of the X and Y that I define is the center. So when I say place this object at X 300 and Y 50, it will place the middle of the sprite to that position. So not this corner, but this here. It is important to know for next steps. So we have an X and Y coordinate. The coordinate system starts at the top left corner, but the sprites, the objects on the screen, have their origin in the middle. Okay. We will get back to the program. Just a second. So if I run the program now, I stop it quickly. You can see that the ball starts from the middle of the screen. I want that to change. I want the ball to start from higher up because it is easier for me to catch it as it falls. So what I will do is I will change the coordinate of the ball. I click here. I will add a line below this. I will say ball Y will be, I will assign to the Y coordinate of the ball the value 50. The line above gives the ball an acceleration on the y-axis, so this means that it starts falling vertically. You could also give it an acceleration on the x-axis, and it will go left or right depending on whether I give it a positive or negative number. But it's not interesting for us now. So I will run the game. And you can see the ball is starting from much higher up the screen, so I have more chances to catch it. Because I gave the y coordinate the value 50, it is much higher on the screen. Next thing I want to do, I want to be able to catch the ball, and if I catch the ball, I want to get a point. When I think about actions I want to implement, I always think, what is the object I'm going to affect, and what is the action that is happening to the object. I want to catch the ball, so my object is the ball. I go one line below, and I say ball. Okay, do something with the ball. What do I do with the ball? Well, when the ball is tapped, I want to do something. What is the function I can use? It's not set speed, it's not set position, set color, it's on tap. On tap is already suggested for me by TouchDevelop. So when I tap the ball, I already get some lines of code completed by TouchDevelop. So when the ball is tapped, it says do nothing. Well, no, don't do nothing. Do something. I want to add a score to my game. I want to add a point to my game. So the object is game. And I have some options here. Set life visible, no. Bounce on sides, no. Current time, all sorts of options. Nothing with score. I move forward. Set life, add score. Perfect. I have the option add score. Add score 1. I caught the ball once, so I give it the score 1. Perfect. Let's see what happens. I play the game. It starts. I tap the ball. My score is slowly increasing. I think you can see that on this part of the screen, right here. So whenever I catch the ball, I get a point. You have to believe me that if I tap somewhere else, like here, my score is not increasing because I'm not tapping on the ball as I instructed my app to do. Okay, so I added a swan to my game. What I also want is I want the game to play a sound. For the game to play a sound, I have to teach my game what the sound is. My game already knows what the pictures are, but has no idea of sound. So I will add a new sound object. Sound resource. I clicked on add, and I have sound resource here. And I will call it beep. And search for a beep. Beep. I have a lot of options. Probably you can't hear the sound, but any will do. You can, if you do this tutorial by yourself, you can hear the sound and test. I will use this beep. Here you can play back. It's a short beep. You can add a description, and it is now under art. Under art in my game resource area. So if I go back to the code part, when the ball is tapped, besides adding the score to the game, I also want a sound to be played. So right below add score, I want to play the sound. The object is the sound, the action is to play. The sound is an art resource, so it's under art. TouchDevelop already suggests one of the 3 art objects I have, park, football, and beep. This time it's beep. And I have several options. Store in variable, not interesting. Replace sound, not interesting. Play is good. I will play the sound. Now if I run the game, every time I tap the ball, the sound will be played. Okay, I won't do that now because you won't hear it anyway. So far, what I did was, if I tap the ball, give me some points and play a sound. But what I actually want to do is simulate the ball kicking game. Every time I tap the ball, I want it to jump up and down. What that translates to is setting a different speed to the ball. So I will say, if I touch the ball, set speed, and I have parameters to give function. I can give it a speed on the x-axis and the speed on the y-axis. So I will say ball, move 50 on the x-axis and move upwards on the y-axis because I want the ball to jump upwards. And because the coordinate system starts from the top left corner, if I want the ball to move upwards, I have to give it a negative speed. So I will say minus 200, for example, just numbers, you can play around with them. Okay. So I give the ball some speed. I will run this app. Let's see what happens. Please let me know if you can see the ball jumping whenever I tap it. Can you see the ball jumping a little to the right? Okay. So what you can notice is whenever I tap the ball, it only jumps to the right. Hardly. Okay, then I can show you a YouTube video of that. Can you see the YouTube video? Great. Okay, I play it again. It's a different ball because I recorded with a different artwork. So every time you tap, the ball moves a little to the right. And the reason for that is that I used two speeds. So the x speed was 50 and the y speed was minus 200. Having the y speed minus 200 makes the ball jump up. And having the x speed 50 makes the ball go to the right. If I wanted to go to the left, I would need to add a negative speed. It would be minus 50. But I don't want to fix that. I want it to be random. So every once in a while I want it to jump to the left, and every once in a while I want it to jump to the right, just like in real life, so it's difficult. This randomness factor can be built into the game. I will start sharing again. I think you can see my screen. So I don't want this speed to be a fixed speed. I want it to be a factored speed. For that, I will define a variable. I say, well, I want a bounce factor for the x-axis. And for start, let's say it is 50. And I no longer want to use this 50 as a bounce factor, but I want to use this variable, bounce factor x. You can't see my screen. Okay. Okay, now? Okay. I will go through it again. So what I did while you were watching the ball and I was talking here by myself was that I defined a new variable called bounce factor x, that is 50. And instead of using the direct 50 value in setting speed, I use the bounce factor. It's basically the same thing as, remember I studied the theory part. Computer, whenever I say bounce factor x, remember that I'm actually saying 50. So I changed nothing in the program in the end. Now I want to introduce this randomness thing. The computer can help me by generating a random number. And if I tell my computer, like as an idea, give me a random number between 0 and 2. It will give me either 0 or 1. And then I can give that logic to the computer saying, if the random number is 0, then I want you to move to the left. And if the random number is 1, then I want you to move to the right. You will understand in a second. I declare a new variable, and I call it randomness. And I give it the value. Random is a mathematical function, so math random of 2. Random is a function that's in the math library. Math is a library, and it is described in this blue area right here. So it says random returns a number. It returns a random number between the two limits you give it. 0 is the default limit, and the upper limit. Limit is the 2 we are using here. So if I say random of 2, then it will return either 0 or 1. If I say random of 20, it will return a number anywhere between 0 and 19 including. But in this case, I want a 50-50 chance of one direction or the other, so random of 2 is enough. Good. I define this randomness factor. And I want the computer to make a decision based on this randomness factor. If I clicked on if, the randomness factor is equal to 0, which is a 50% chance because randomness can be either 0 or 1, then instead of doing nothing, I want the bounce factor to be, so I assign it a new value, to be minus 50. So basically, I start off with a default bounce factor of 50. And then I ask the computer to generate a random number, and if that random number is 0, then I want the randomness factor, the bounce factor, to be minus 50. Let's see what happens. I run it here, and I will show you a YouTube video as well, so you see it better. So sometimes it jumps to the left, sometimes it jumps to the right. Let me also show you the YouTube video. Can everyone see the YouTube video? Perfect. I play it again. When I click, sometimes it jumps to the left, sometimes it jumps to the right. It's quite random. But still, you can notice that when the ball falls down, the game is continuing to play. Of course, because I didn't write any end game code. We'll do that next. I will continue with sharing the screen. Okay. What is the logic behind verifying that the ball has reached the bottom of the screen? Well, what I can do is, what I should do actually is check where the ball is. We talked earlier that the ball has a certain position on the screen, and the computer program can check every time something is happening. In this case, every second, let's say. See where the ball is, and if the ball's position is exactly at the bottom of the screen, then the game should stop. I will write that code right now. Where do I do that? I do that as the last thing in my code. The object that I'm working with is the ball. I want to check the ball's position. So I say ball. I have some options. I can check something on a tap, but this is not correct because I don't want to check the ball's position when it is tapped. I have more options here, but nothing that I think will help me, like set angle, set friction. These don't give me any hint of what I want to do. So I have this option to search more. As you noticed, with the on tap thing, actions are with on. They start with the keyword on. So I will search here on. I have several options: on tap, on drag, on every frame, on swipe, on touch. They are all explained. And in this case, I want to check very often if the ball is on the bottom of the screen or not. So I will use on every frame. Every frame means basically every time the ball has to be redrawn. It's quite technical, but just remember that on every frame means very often. What I want to do, I will comment. Comment is a line of code that is not executed, but it is helpful for other programmers to see what I wanted to do with the lines of code that will come. So I will comment. I want to check the position of the ball, and if it is at the bottom, I want to end the game. So I added this comment. This does nothing to the program itself. It helps me as a developer if I come back later and I don't understand my code to see exactly what I wanted to do. Okay, so on every frame I want to check the position of the ball. That means, for me, okay, let's see what the position of the ball is. I'm not interested in the position on the horizontal axis. I'm interested only in the position on the vertical axis. That means I want to see the y coordinate of the ball. I will add a line of code. I declare a new variable that's called ball position, like that. And I will say the ball position is ball and its property the y coordinate. It's explained right here. Y returns a number and it gets the y position in pixels. We started up with 50, and as it falls down, it grows and grows and grows. Okay, so ball position will tell me exactly where the ball is. My next logic is, if it is at the bottom, I want to end the game. How do I check if it is at the bottom? Well, if it is a condition, if the ball position equal to the board's height. The bottom of the screen is exactly the board's height. If it is equal to the board height, then I want the game to end. Then game end. Okay. This is basically the logic that I described in the comment. I want to check the position of the ball, and if it is at the bottom, I want to end the game. Let's see what happens. I know you can't see it properly, but you can tell that even if the ball is falling, the game is not stopping. So there must be something wrong with my code. What is wrong with my code is what I explained a bit earlier on the whiteboard, that the coordinate system of the objects on the screen has its origin in the middle. So whenever the ball bounces, it bounces off from the bottom. I hope you can see the whiteboard. Therefore, the position of the ball will never reach the bottom because it is right in the middle. So in the worst case, when the ball is reaching the bottom of the screen, the position, the central position, will never be as long as the height of the screen. Therefore, I have to change my logic a bit. I also have to take into consideration this height difference here. So the real ball position is not ball.y. I will switch just a second. It's not ball.y. It is ball.y plus ball height divided by 2. It seems odd, I'm sure. But due to the fact that the coordinate system of the sprite starts in the middle, you have to take into consideration the half the height of the ball. And now if I run the program, it still doesn't end. I wonder why. I made a mistake, probably. I will also take some error calculation into consideration to give it a threshold of 5 pixels, because maybe with the frame is being drawn too fast, it won't take the ball doesn't touch exactly the end of the screen. So I will give it a 5 pixel error margin. Let's see what happens. Still nothing. Well, yes, I made a small mistake, a small but fatal mistake. I don't have to check if the ball position is exactly board height minus 5 pixels. I have to check if it is larger or equal. It will never be exactly as calculated. There will be always errors. So finally, now you can see that my logic is finally working, and the game ended when the ball fell over. I want to do one more thing, and that is remove the ball from the screen when the game stopped. And that's a very simple command. It's called ball delete. If I run now, after the game over animation is played, the ball disappears from the screen. So this is a very simple game written in something like 20 lines of code with some help from TouchDevelop. We've built everything into it that was in the demo from the beginning. Calculating the score every time we touch the ball, finishing the game when the ball reaches the bottom, making some mistakes and showing you how I debug those mistakes, giving it some margin for error, adding some comments. I also showed you how you can search for more functions. Here I can always search for more. Use the search on the right hand side. When I'm stuck, I always can go to help on the bottom of the screen, where I can read the documentation. The documentation is a little bit cryptic, at least for me. That's why I recommend you use the tutorials, because you will learn step by step what you can do. And also for the people you're going to teach, starting off with a tutorial is always easier than reading the help and then doing some work. You get lost in the help. Here you can get links to tutorials, but you can also find things like what I can do with the sound. I have in the search area, if I type sound, It suggests a list of things, and if I click on sound, for example, I have all the functions I can use for working with the sound. What I used was sound.play this here. So that is a very useful tool, the help system. Okay. This sums up the tutorial, the game I programmed with you. Stop sharing the screen. Getting back to the slide. Well, I see that someone suggested that I should use minus ball height per 2. But no, because the coordinate system starts from the coordinate system of the board starts from the left top part of the screen. So if I want to go lower, then I have to add things, not subtract. Okay. In the slides, you can also find the code I demonstrated. You can take a look at them later and do the tutorial yourself. Now we have some time for questions and answers if you have any questions.
Hi, this is Agnieszka today again. I haven't seen any questions apart from those that Anna have already answered. So if you have some other questions, please type them down in the chat window. I remember one question from the beginning. Someone asked about the presentation, if it will be available for download, and I guess that we will have this opportunity. Anna, am I right, to download the presentation?
Yes, I sent you the presentation.
Okay.
And it is also available here in the webinar. I don't know if you can download it directly, but I can send it again to anyone who is interested, of course.
Okay, the webinar is recorded, so we will decide on the way to make available this for you, because the meeting lasts more than 1 hour, so the file will be perhaps larger than 1 gigabyte, so it may be not easy to make it available to you to download or send you. So if the organizers decide to make the file available on some service like YouTube, for example, or another one, so we will inform you, and we will decide also about the way to make available the presentation to download. It's will you be sending us a link to
I see a question. What is the age of the children? So the question I would like to answer is, what is the age of children you teach this to on average? I think 10 years is the average, but sometimes we have children who are the first grade, so around 7 years here in Romania. What is difficult with children this small is surprisingly not the fact that you have to teach them coordinates and things like that, but using English. English is the main language of TouchDevelop. I honestly don't know if you can change it to any other language, but that's the main problem. Functions and variables and tutorials are all available in English. That's the most help they need with. Yes, of course, you can upload on my side, of course, the webinar to YouTube. I don't know about the organizers of the webinar, but from my point of view, of course.
yes, we will need some time to download the file and make it, you know, right for presentation. We will shorten it. We will get rid of the warming up of the beginning, so the file will be in a better way to use it later, and it may be also shorter and more better for making it available or sending, you know, transferring using some feature. We do not know how much time it will take us. Perhaps we will try to make it as soon as possible, but it will depend also on the organizer to decide which way of presentation and making available of the file they will choose.
Regarding the most popular scenario, use TouchDevelop. To be honest, I use mostly Scratch. TouchDevelop I just discovered, and I'm looking forward to try it with children who are bored of Scratch, because it looks more adults, more like an adult way of developing, and they might be interested in it. But to be honest, I think they would love to play with the Flatverse tutorial that is very similar to Agario. We also did that with Scratch. And I'm curious how they will react to TouchDevelop. Great, I'm curious to find out what your opinion is on the subject. I tried to go through a scenario that is on a good level for everybody who may or may not have worked with programming before. I wasn't sure exactly what your level is, but if you have more complex questions, I would be happy to answer them next time with the next webinar. At the end, we will continue with Kodu. Kodu is a much different tool. It uses 3D graphics. We will use YouTube more often because the screen sharing is not very good in this case. And we will have time to answer questions regarding TouchDevelop as well. So if there are no more questions, that is it on my side. I hope you learned something during this webinar. And I encourage you to get the tutorial, this one and everything that is on the Microsoft website for yourself.
Okay, so thank you very much, Anna, for your presentation and the training. Thank you all for being active, and we really hope that the meeting, the webinar, will be useful for you. The next webinar will be on Monday, so see you on Monday. Bye bye.
See you on Monday.